Regular expressions, or regex. The search function allows you to search for specific text. What regular expressions does is it allows you to search for text based on patterns. So using a function to identify something like a phone number, you can see we have a phone number here, and the functions would be, we can do the length to verify it's less than 12. If it's less than or equal to 12, we're going to return false saying it's not a phone number. Now we can do a check and look for the first three positions of a string, 0, 1, and 2, and confirm whether or not it's a number or not. Then the next step we can do is check position 3 right here and see if it's a dash. And it's kind of a complicated problem going through and checking each character. There's a lot of code here, a lot of steps. And then what happens if the phone number is in a different format? Now positions 0, 1, and 2 are no longer numbers. With regex, we're going to use symbols to do pattern matches. We're not matching any specific characters. We do have the ability to match a single character. We can match text, but it also gives us the ability to match text at the beginning of a string, text at the end of the string. We can match by occurrences, 1 or more, 0 or more, and we can match alternate texts, A or B. The pipe represents the OR symbol. And we can match a range of text also. Regex also has character classes. So using the backslash, we can represent any digit, and then a capital D \D would be any character that's not a digit. We also have the \W for any letter, number, or digit, or the underscore character, word characters. And we can do a \, escaped capital W, any character that is not a letter, number. We can match any spaces with the escaped lowercase s, and an escaped uppercase s represents any character that is not a space tab or new line. So let's take a look at how we could match a phone number. And this is the actual expression to match a phone number. This looks a little bit overwhelming and confusing, but if you break it down one part at a time, it's not that bad. It's actually a lot simpler than using conditional logic to verify or find information. So one thing I like to do with regex is I use the site regex101.com, and this is a great place where you can take a test string and you can start building a regular expression to do your matches. As you can see here, this test string matches phone numbers in all these different formats. One line of code, much simpler than using conditional logic. And it does indeed filter out stuff that's not a phone number. For example, here is the letter O, and the one below it has a comma instead of a period. So let's take a look at the expression to match a phone number. So the first thing we do is we escape the parentheses. We have to escape the parentheses because it's a special character. We have to make sure our expression understands that we're just trying to match the parentheses, not do anything with the group function. And then we put the question mark after it to show that that's an optional. You could have a parentheses here, but it's not required. The next step is we're going to look for 3 digits. We want 3 consecutive digits with the escaped D followed by the 3 in curly braces. And then the last step, of course, will be another optional parentheses. So that's how we match our area code. Now the next step is we have groups in regex, so we can use parentheses to define a group, and then we can match for a space or a hyphen or a period. And then the question mark at the end of this makes this group optional. Using regex to find a phone number, now we're going to look at the separator. Space, hyphen, or dot, and it's all optional once again. Now if we want to find the prefix, that's just simply the first 3 digits of the phone number. That's just an escaped D followed by 3. And then the next step again, we're going to take a look at the separator and then 4 digits. So if you break this out into just a little bit at a time, if you can break an expression into chunks, and actually finding a phone number is fairly complicated for regular expressions. And then the last step is the 4 digits. So let's take a look at how we could use regular expressions to find information in a network device. In this example, we're looking at the output of the show version command on a Cisco router. And look, there's a lot of information in here. I'm going to toggle through some slides to look at it. We could be looking to identify all kinds of things. The software version, maybe the compile date, that might be information. The iOS, the software family, is it an iOS XE, iOS XR, and XOS? And we could want to find the uptime. We might want to see the image file and find out if the device has the current operating system on it. And there's just a lot of information in here. Obviously the license level is important. There's just a lot of good information in the output of show version. And this is all stuff that we might want to search for without necessarily knowing what we're trying to match. And of course we have memory and VRAM, physical memory, flash memory, the configuration register, all kinds of information here that we might want to search for. So let's play around with this. If I go to regex101.com, I can indeed match all occurrences of Cisco, but that's really a little bit too broad. We might want to filter that down. If I put the caret in front of the Cisco, that's the symbol above the 6 character, number 6 if you hold the shift key, we can find any line beginning with Cisco. If we want to find a line ending with the, we put the $ after the word the. And if we're not sure about the case of it, we can put inside of square braces a uppercase key followed by the pipe and then the lowercase t. If I wanted to find the memory using regex, well, I could search for the word memory, but I've got multiple occurrences of this. And then if I want to look for the word bytes, I still have, in this case, I have 4 occurrences. We need to filter this down a little bit more. I can look for consecutive digits. This is kind of a sloppy way to do it. 1, 2, 3, 4, 5, followed by dot star. The dot represents any character, and the star represents any occurrence, any number of occurrences. So this is pretty much going to match every character until you get to the end of the line. And then if I wanted to filter it differently, I could do a range. So now I'm looking for a digit, 5 to 20 occurrences of that digit, followed by any character, and then we stop at the uppercase K. So now we're getting the memory filtered out, but we need a little bit more so we can define which type of memory we're looking for. So I can do it this way, and this way I'm using grouping. So my first group is going to be any digits from 5 to 20 occurrences, followed by any character ending at K. So that's my first match right here, 3295007K. Then I'll represent a dot star, and that's going to represent any occurrences of any other characters. And then the next group is going to begin with the word boot. So now I've got my regular expression match, and I'm matching the 323.295 million K of memory in boot flash. Now using these groups, we can look at it in Regex 101. On the right hand side, you'll see a little bit more detail of the groupings, and it shows the group numbers, group 0, group 1, and group 2. And we are indeed still matching the memory, and it's 3 separate groups. And the nice thing about this is we can reference, we'll show you later how to reference those groups specifically. So we have another concept with regex. We have greedy and we have non-greedy regex. Greedy mode matches as much text as possible, and that's the default mode. Non-greedy matches as little text as possible. With greedy regex, if I do name : dot star hyphen, we're going to return all text. We see the hyphen, but it's not going to stop there. We're in greedy mode now. It's going to keep matching all the way until we get the hyphen at the far right side at the end of our line. Now if I wanted to match just this, maybe I just wanted this component here, WAN interface card. Maybe I don't want the rest of this. So what I can do is I can use non-greedy matching. And see, there's the first and the last hyphen. So we really want to stop at the first hyphen in our search. So for non-greedy regex, it's really pretty much the same. The only difference is after the dot star, or kind of like my wildcard, my infinite wildcard, any characters, any character type, I'm going to put the question mark. And what that does is it tells this asterisk that you're going to match, but you're not going to match as many as possible. And then we can end the group with the hyphen. And now we've got this broken out into name. We've got it separated for WAN interface card. And then we've got a third group for the hyphen. So now if we wanted to find the software version, we can do some more examples here. So now I'm searching for the word beginning or the string matching, and it starts with a capital V inversion and then then a digit followed by dot star. So now we're going to get version. Actually, there's a space here too, and that space is important. So now we have four different matches. We're getting multiple results. If I want to add a comma in here, I can get more details. So it's the same pattern match, except I put a comma at the end, and that filters us down to 2 matches. And lastly, we can filter this out even better by matching for any line with Cisco iOS software, and then any other text, and then we'll stop that first pattern at the word version. Notice I have a space here also because I want to capture that white space also. And then I'm going to match a digit followed by any character, and then the next match will be the comma. So this filters out 16.12.4 VS3.